thank you everyone for coming, making the long trip from the other side of the building. So yeah, we're going to talk today about a product that we have built using MarkLogic, which we call LUX, which is not an acronym, even though it's all in capitals. It is just the first letter of Yale's motto, Lux et Veritas. So what is LUX? We think of LUX as a groundbreaking discovery and research platform that provides unified digital access to the collections of our museums, libraries, and archives. So the two highlighted words then are unified and collections. We're going to focus on that first, then have a demo and then talk about how we built this. As you can see on the right-hand side there, it's reasonably substantial number of records, about 41 million records altogether. If you expand it out into triples, it's about 2.7 billion triples, all managed in MarkLogic. We've been in production for a bit more than a year now, June 1st, 2023, with zero downtime. We have a great blue-green switch where we can fail over. We've never needed to use it. So, collections first, and then what do I mean by unified? So, for our collections, we have 4 main organizations within Yale. The Yale Peabody Museum of Natural History, the Yale Centre for British Art, and the Yale University Art Gallery, right across the road from it, and the Yale University Library. Depicted here is the Beinecke Rare Book and Manuscript collection within that. So when thinking about what we wanted to do with LUX, we wanted to make sure about that unified, to have consistent records within a single system, rather than just sort of a federated search with multiple records for the same entity coming up all the time. So how are we going to do that to make this coherent across the natural sciences, all of the content and topics in the world in the library, and our 2 art museums? So of course we noted first of all that everything is connected. So here is a fish. It has a Latin name that I have learnt to not try to pronounce. It's at the Peabody Museum, discovered by Benjamin Silliman, an early Yale professor. Benjamin Silliman wrote this letter in the archives in the library to Sir George Peabody, Esquire. Dear Sir, blah, 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 please give us some money because we want to make this museum into a world-class organization that it is today. This is Harriet Trumbull, who is the niece of Silliman and was married to John Trumbull, the famous revolutionary artist, who, along with his mentor, Benjamin West, painted this painting, which is in the Yale Centre for British Art. So starting from a fish, through to an archived letter, a sketch in an art gallery, through to a painting in the YCBA, we can, just this one particular instance of essentially a knowledge graph, where we've been able to connect the resources together in unforeseen ways. So then what do I mean by unified? And there's 3 main components to this. The first is reconciled. So there should be one record for each entity in the system rather than one per source database. So we have 4 major collections, but the library has the books and the archives separately, so there's 5. We also have the collection of musical instruments from the School of Music, the campus art collection, the library and archives and photo archives in London at the Paul Mellon Centre, and a collection of photographic paper at the Institute for the Preservation of Cultural Heritage. So if we had all of those contributing records that weren't reconciled, it would just be a complete mess. So there on the side, you can see there is 5 records that have been reconciled for Benjamin West, Trumbull's mentor, from internal sources, and then more than a dozen from external sources such as the Library of Congress, Name Authority File, Wikidata, Wikipedia, VF, ULAN at the Getty, and many more. It should also be enriched. So because we did that reconciliation with the external sources, we then get to be able to connect the knowledge that those sources have with ours, to have a much more interesting, engaging user experience, and to move towards research from just simple discovery. So we do not manage the Arabic, the Chinese, all of these different names that we have for West here in the slide, those all come from external sources. We just have the one name in English. And finally, they should be connected, right? From this person, you should then be able to see all of the other museum objects, library records, archival records that have something to do with West. So, for example, the leftmost is the objects that he created, encountered, or influenced. Then the works that he created, so the books and the archives, and then works that are about West rather than created by him. So what is Lux really? It's a knowledge graph that provides unified digital access. What is a knowledge graph? So if you've been in any of the sort of semantic modeling sessions earlier, you'll already know the answer. But essentially, this is the hardest point of a knowledge graph, which is the blank whiteboard, and you have to start somewhere. So we'll pick the painting. So you start with a single entity, and then you start to connect things onto it. So for example, this painting was created in an event that took place at some point in time. That event was carried out by Trumbull, and it was carried out by West. So now we have these references out to some other people, but you could still manage that in a regular record, right? Those entities can be conceptual, so a reference to what sort of thing is this? It's a painting. They could be geospatial, so it depicts La Hogue, which is a place in France. And now we start to get into a bit more interesting graphness. So those entities can participate in hierarchical relationships, such as painting has a broader term of visual works. La Hogue is within Normandy, within France. You can imagine also other sorts of similar hierarchical relationships. West was a member of the Royal Academy. So this is sort of, we do not use semaphore, but this is sort of the core business case for semaphore. They could also be non-hierarchical, such as an auction catalogue that is about the painting. And now we really have a graph, a full connected network. We also have the archives of Trumbull, which of course was created by Trumbull. It's about paintings, it's also about West, and so on and so forth. Now we have 41 million of these guys in Lux, so I'm not going to show you the hairball of what that would possibly look like. Why would we even try to do this? We're a university, and our mission is around teaching and learning research. But in order to do research, teaching and learning with the collections, previously users had to go to 26 different websites in order to do the complete search, and now there's just one. Right? Users should not know, and did not know, to go to all of those places. They then needed to interact with a whole bunch of different user interfaces, learn each one. They all had different query languages that you had to engage with, and so on. Of course, the end result was horror, right? No one liked this. So that's sort of the baseline for why we did this. It also directly advances the mission of the university, as I was saying, right, which is excellence in teaching and learning, excellence in research, and preparing our students to be leaders in the world that they are going to explore. So we can do that by revealing the world to the students through our collections. Right? And that context that you can get from the knowledge graph by connecting the records together in a user-friendly way helps them to understand the history, understand the past, understand the world they're going out into. Lux also, of course, directly advances the goals of our division, which is to both simultaneously to preserve our collections, make sure that they continue to exist for as long as possible, and to make them accessible. So as you make paintings and other artworks accessible to people, they start to degrade more rapidly rather than being held where no one can see them. So we have seen dramatically that the amount of interaction that we can enable through Lux and through digital means vastly increases the accessibility in the sense of access to, rather than web accessibility, but yes, the accessibility of our collections. It also means that we can improve our decision making because we've got access to this graph that we can then use to understand what we are doing and what we are not doing well, to then allow us to make better decisions about preservation and about access and so on. Okay, so enough chat. Let's see it. And hopefully I'm not bitten by the curse that the other presenters have had. No? Good. And I've also learnt not to try to type in Latin names of species, so let's just search for Trumbull. So we have the simple Google-style search box. You type in keywords, it does a search. Nothing out of the ordinary here. Across the top here, we have these tabs of the different sorts of entity that we manage in the graph. So there are objects, matches 3,000 of them, works, which are the archives, sort of the intellectual hierarchies, and the bibliographic records, the content of the book rather than the physical codex that sits on the shelf. People and groups, and here is John Trumbull. Places, Trumbull County in Ohio, Trumbull County, etc., etc. Concepts, Victoria Trumbull, or property maps of Trumbull County in Ohio. And events. So a lot of the events are exhibitions, in fact all of these 5 are, but we also have things like conferences and so on that we can extract from the bibliographic records. There is, of course, faceting, so it's a demo, we should only show ones with images. What are they categorized as? We'll look for portraits. And between 1780 and about the turn of the century, 1820, 18, oops. So we can quickly, use the facets to filter in. Again, this is not knowledge graph stuff. This is just your regular document search. It's not quite, which Brent will talk about, but for the purposes of right now, it is. So when do we get this graph from? We'll get there in a second. So let's look in particular records. So we have very high quality digitizations of the works. We use IIIF, the International Image Interoperability Framework, to enable deep zoom into the objects. And this, let me zoom out. This is a miniature painting. In real life, it's this big. Right? So if you were to zoom, physically go up and see that, you would have your nose against the painting, and the security guards would be very quickly over to say, please stop wiping your nose on our paintings. We, of course, also have your regular metadata. It's a miniature, it's oil on woods, it was made by Trumbull, and so on and so forth. In a traditional system, though, if you were to click on Trumbull, you would expect to do a search for other objects by Trumbull, right? But because we have the knowledge graph, instead you are taken to a record about Trumbull, right? With all of, as we explained before, the connections to within the collections, so the objects that he created, works about Trumbull, either visually or textually. If we scroll down, we can then produce a timeline, and we have a demo version of a real timeline rather than just a list of dates. But it's not quite ready for production given the 41 million scale. If you get a timeline of all books, it's a very bad idea. However, I'll skip through some of these, the real benefit of the graph is that we can leverage it to produce on-the-fly information like this. So who was related to Trumbull? Well, Theodore Sizer created works about Trumbull. He created works with Trumbull, and is the subject of works that are also about this person. Or Benjamin West. So here is the connection to West. Co-created objects with this person, one result. And here's the painting. So it starts to reveal the hidden relationships that are implicit in the data in a much more visible, obvious way, and without losing the fidelity of those relationships, right? You can see the extent to which Sizer and Trumbull collaborated. Here are the records that we contributed, coming from the systems, internal systems, external records. All of the data is publicly available. It's all CC0. You can use it. Here's the enrichments, right? Here's the link to Wikipedia. All these occupations and roles. We don't manage almost any of that, and so on. Oh, there's the names. Of course, we know that he died in New York City. We can go to New York as a place. Turns out we have a lot of stuff in New York. It's only an hour and a half by train away from us, with all of the same properties. Right? So we can see who was active here, who was born or died here, what are the related concepts, related people and groups. Calvin Klein created objects at this place, for example. There's also subjects. So I won't click through to the object. I'll click on the type. So here's the concept of sugar tongs. It turns out the art gallery really loves sugar tongs. Don't ask me why. 737 unique sugar tongs in the collection. So yeah, we can leverage the graph to show these connections. We can also do it. I won't do the search by hand, but we can also use it for querying. So this is my favorite advanced search. We're looking for objects that are categorized as being a painting and include a work that's about a person, and that person encountered some object, and that object is categorized as a concept that has the name of fossil. Right? So it's paintings of people who found fossils. Now this must connect across different organizations within Yale, because there is no museum that has both paintings and fossils, right? It's the Peabody and the Art Gallery, all YCPA. And here they are. So here's painting of Benjamin Solomon, of James Dwight Dana, another one of James Dwight Dana, O.C. Marsh, the famous paleontologist. So just to prove it, so here's the object. It's a painting. It shows a work which depicts Marsh, who discovered all of these fossils. Right? So you couldn't see it, but it had, because the screen real estate isn't enough, but that search is sub-second, even though it's spanning across hundreds of records, certainly, probably tens of thousands given painting and millions given fossil. So, yeah, we could go into a lot of detail around the individual advanced search stuff, but suffice to say, with MarkLogic, unlike with triple stores generally, where you know that people are using your triple store because it's down, we can give access to the graph to every user. We've stress tested up to 150 simultaneous users. We've never hit that, but that's our target. Let me go back to these slides. How did we do this? Collaboration, first and foremost. It's across all of the museums, libraries, the archives, central ITS, and of course with Progress MarkLogic. Brent is our wonderful consultant, and we've had great support from the MarkLogic team. And by hard work over several years, we had more than 100 people directly take part in this over 5 years. So not 500-person years. We're rich, but we're not that rich. So there was a core team of 7, including myself and Jeff Campbell, Brent, Peter, yep, and a few others. So why with MarkLogic? So the requirements before choosing to go with MarkLogic were it should be unified, so reconciled, enriched, and connected. It should be usable, right? This does not give a Sparkle query to a student and hope they figure it out. The interface must be engaging and intuitive, right? It has to be something that people want to use because we can't force them to. Should be performant, and our original requirements, which we have more than beaten, were keyword searches should return in less than 3 seconds, and advanced searches should come back in less than 6. It should be implementable, right? You can't require someone to have a PhD in graph optimization in order to maintain a collections database, because that person who has both of those skill sets doesn't exist. So instead, the front-end engineer, Cameron Larkins, who's not here today, was a year and a half out of college when she joined the team. And was able to very quickly get up and running to build the interface, and Peter looks after the back end along with Brent and so on. And open. All of the data and code should be as open as possible. Of course, we can't open source MarkLogic server, but all of the additional configuration, all of the data, all of the front end is all open source. It's on GitHub. If you go to Project Lux, you can see it. So the implementable one, just to drill down into that one a little bit more, we think that records are a necessary concept along with the graph. Right? The graph is not really a comprehensible notion to anyone, particularly when you've got 2.7 billion triples that you need to interact with. So you have to divide it up somehow, and you could either construct those partitions of the graph at runtime with Sparkle Construct or similar, but that's hard unless you actually are a Sparkle guru, and it's expensive, particularly when you don't need to do that because you can pre-construct the records and then use all of the multi-model technologies in MarkLogic to get the performance aspects that we've been able to achieve. So we need records as a concept, as a thing, for all of the requirements, it turns out. So for unified, you need something to link from and to. You need an anchor within the graph that's comprehensible to someone when they see it. Usable, graphs are not easy to understand. You need that unit of search. What are you searching for? You're searching for an object. You're not searching for a URI or a triple or a statement. Performance, semantic facets are really expensive when you've got 2.7 billion triples to deal with. So we use semantic facets very rarely. I think there's 2 at the moment out of all of the facets. However, MarkLogic is very good at doing regular record-based facets, which we can use because of this record construction. Implementable, graphs are hard to work with as data, and open. It allows others to use our data in their system because most people don't have MarkLogic, but they do have easy access to things like Elasticsearch or Solr or similar. So we can give records to others that they can then understand and use. But to build Lux, the multi-model functionality is therefore a necessity. Right? In order to benefit from a true, real production knowledge graph and give users access to the semantic query, it has to have both the record-based stuff for the searches and for relevance ranking and so on, and the graph-based at the same time in the same query, even for simple search. Because when you search just for Trumbull, note, it matched objects that didn't have Trumbull in their record. It matched objects that were created by Trumbull. We haven't denormalized any data. All of the data of names is in the person record, not in the object record. So when you search for Trumbull, just typing it into the keyword search, it's actually doing a joint query, both record and graph at the same time for every keyword. Okay, go back to why with MarkLogic, and why MarkLogic in particular. So we had a robust evaluation process. We had 6 teams that evaluated 8 different products over the course of 4 months. We tried to get as much variation into that evaluation as possible, either a single system like MarkLogic or an integrated architecture of pulling together a triple store and a document store and a document query language. Open source versus licensed products, established versus startup, a bunch of other, I think there were 8 primary axes that we were trying to establish. It turned out that MarkLogic was the only system that could meet the requirements. And architecturally, it's an obvious choice, right? You can either have a product that does it for you with a single API, or you can stitch multiple products together that would give you the open source option, but the amount of effort needed for the engineering to just do that text graph merge would have blown away our budget entirely. there were also some political requirements. So when we started thinking about this, it's like, oh, this is going to work. We'll use MarkLogic, and we can do this, we can do that. But the museums and libraries essentially said, but are you creating a new system of record? What happens when you update something over there? How do we get the changes back? What happens when we update and you update in collisions? So a semi-technical, I guess, requirement was no new systems of record, right? This is only for discovery. The system of record is in the library. It's in the museum. It's in the archives. So it has to be rebuildable from code. Right? If AWS were to get blown up, we could be back up and running with minimal data in less than a day, and the full everything would be about a week. Most of that is network traffic to the external records to just suck them in and do that enrichment process. Equally, there shouldn't be an editing interface or any custom persistence for that same reason. The asterisk, well, we do have a few hundred rows in spreadsheets just to tweak things that if we didn't do that, they would be very embarrassing and sweat mark. So yeah, equally, the data owners were like, well, we don't want you to be replacing our systems. We're going to keep doing our discovery in our way for our users. So yeah, we did not go into this thinking that we would reduce the footprint. It was expand the access. And secondly, everyone is welcome. It has to be cross-domain. So when you're dealing with a library with 15 million books in it, then cross-domain is everything. It's human knowledge, right? We have everything from CRISPR and genetics through to ancient history, philosophy, psychology, engineering, everything. So in order to engage with the library, we had to engage with the world. It should be easy and enjoyable to participate. We shouldn't be expecting that all of these data owners are going to spend a lot of their time to help us build our system. Right? They're engaged, they're stakeholders, they're owners, but they also have their own day-to-days that they need to take care of. And so both the work process, thus, must scale, as well as the product. How do we manage that? So here's the architecture. We have the source systems along the top, with 6, but 2 managed by the library, the first 2, and then the middle one, which says UAG, CAC, CMI at the top, is the art gallery, campus art collection, and the collection of musical instruments are all multi-tenants in a single system. Then at the far right are the external data sets that we pull in. So I always, when I'm drawing diagrams, try to put the network in red as a reminder to everyone that this is your bottleneck, right? As soon as you hit this network thing, you're slowed down by a factor of 1 million. So we have scheduled harvesting to pull in the changes from each of the systems. We use a W3C standard called activity streams to manage that so that we can get only those records that have changed at whatever periodicity the providing unit wants. We then transform the records into a single structure, into a single ontology, reconcile them so that we end up with 1 record rather than 8 for the same entity, re-identify them so that we're not having to pick one identifier for the record. So, for example, when we get a record about a book from the library, we give it a new UUID, and then we persist that identifier rather than using the libraries. Because when you have a person who's in each of the collections, you can't make that choice. So it was just easier to say, all right, everything gets new identifiers. So at that point, we haven't done any merging yet. We've reconciled it. We know that this is that, but they're still 2 separate records now with a shared identifier. So the merge process finds all of the copies with the same identifier and merges the knowledge together into a single record. We then load currently with MLCP, but we'll certainly be looking at Flux in the future, into MarkLogic. That takes about 4.5 hours at the moment to load 41 million records. It's about 500 gigabytes of JSON LD. On the front end, we have the Lux platform in terms of front end, so it's built in React with React Router. There are then a series of web caches, including CloudFront and a varnish cache, to ensure that only the queries that have not been run recently actually get back to MarkLogic. The middle tier at the bottom that connects to MarkLogic deals with blue-green switching and some re-identifying of things, so that we can have two instances. We reload one and then use the middle tier to swap to say, all right, production was this, now it's that. Now we reload this one with the next data set, swap back. So that's how we have zero downtime, right? Because we use the middle tier, just change the configuration, press the button, done. And with that, I'll turn over to Brent to talk about the implementation.
Good afternoon, and happy almost break time. So we've been talking about multi-model search quite a bit already, and especially with keyword, it is not just looking. You've got your document data and you've got your triples, your triple store, the semantics, the connections, right? And when just a simple keyword search is not only looking in those documents, but it's going to take a semantic hop over and look in those documents too. We're picking which one, but nonetheless, we are looking around and not just in one spot. You then saw his example where he was jumping pretty deep. It just kept getting, the nesting level kept getting deeper. Every time that symbol changed, it was a semantic hop to a different entity type. And then you give the user a guided advanced search, and you're showing them what's available at that point. So you don't need to know up front everything that Lux has. Rather, have a point of interest where you want to start, and then see what's available and start adding up your criteria, narrowing down your results to what you care about. Related lists. One of the features that made me question Rob's sanity. It turned out he's right again. It's hard to prove this guy wrong, but what's happening in the background is you have 12 to 25 triple searches. So every time you're starting with a person, a place, a concept, and you're saying, tell me what's related to this thing. And we are running those triple searches and collating the results and then sorting them for you. But because the triple store is so large and there could be 25 triple searches in this one user's request, we cap it at a mere 250,000 triples per search. But that's times the number of relationships. Indeed, good feature. So now we can tell you how this is, how many times is are these two entities related, and how are they related, and then the next one, and the next one. Semantic facets. So your traditional facet, the data that you're faceting on is right there in your document. We know them, we use them, we love them. But then what happens when you want to facet by something in a related document? Well, we're Lux, we have the multi-model. We're going to jump over there, grab that data, bring that back to you for you to facet on as well. And a little plug for Optic, it's even easier in Optic. All right, search will match. The name, I probably could have come up with a better name, but it's accurate. So when you have, somebody's asking for an entity page, they want to see a place, and you have 20 or so UI controls. I think this was another brainchild of yours. Don't waste the user's time. Don't take up space if you don't have data for that widget for this entity. So go ask the back end, hey, do you have at least one result for all 20 of these? So in one request, we're doing about 20 searches where it's page one, page length one, a filtered result. We're going back, and now the UI knows which ones to display. Data slices are the up-and-coming feature. We've pretty much vetted it, and we're looking forward to deploying it not too far distance future. But the concept here is, great, you built this Lux, you've got all this great functionality, it's a success, but how can I, as an individual library or museum at Yale take advantage of this. Because I've got a web portal, and I want to continue having a web portal, and I only want to serve up my results, but I also want your functionality. So now we can have a single production instance of a MarkLogic cluster, and we'll give you a service account. We've already know who's the contributing records. When you do your search, you're going to be limited to that. It's comprehensive of the triples, whether this document from a different unit knows about you or you know about them. If the search result is not, if you're not a contributing, if you didn't contribute to that record, you're not going to see that data. It's locked down. At their request, if they wanted more documents, we would give it to them. All right, so what's underlying here? We have this, all of these features, practically all the features except give me this document, are using search. And it's the same syntax that have this about 180 search terms. 93 of those are semantic. 93. So that's quite a bit we couldn't do if we only had one or the other. And there's 80 for the document, and then 8 that span it. It's that keyword search over that's 8 different search scopes. We have 12 search patterns that those 180 terms will map to one of those. That's allowed us to make an optimization and roll it out to all applicable search terms right away. We have configuration generators too, so we mainly maintain the configuration of some search terms, then we generate the rest. Then we take that output and we'll generate all of the related list configurations by walking through that configuration. So that related list configurations, this is not the business track, is it? Y'all wanted some tech a little bit? What the output of the related lists configuration are a bunch of search criteria. We also generate the advanced search configuration that the front end loads up, the one that guides them. We're able to do all this on a 316 vCPU cluster in AWS, and I took a random 24-hour period, and of the 390,000 requests, we almost got 3 nines. It is CTS today, but we've been looking very closely and pressing Optic, working with James Kerr, and it's coming along nicely. It's holding its own. A little bit more of a breakdown for those search terms by the class or the entity. 6 of them are exposed, 6 of the entities are exposed to the UI, and this will just give you an idea of how many terms per. And then you got a few arrows, so they're just talking about how that configuration is being used to generate more. Back to you, sir.
Thank you, Neil. Try and put this back without making too much of a noise. Okay, so improvements that are underway. So 2 halves, the knowledge graph and the system. And we're getting in more collections all the time, more external data for enrichment, more internal data from different parts of the university. We're also looking at improving the ontology and the modeling. So in working with the Peabody Museum, they have the notion of a stratigraphic layer, so essentially a layer of rock in which the fossil was found. So it's not a place, anyway. So there is a lot of discussion about how best to deal with that in a simplified world of place versus object. And increased alignment with standards, of course. The system, we want to move to Optic in order to get things like fully transitive triple queries to say, I'm interested in fossils from California, but the fossil knows exactly where it was found, and then we want to be able to crawl up the spatial hierarchy to say any of these places, but that's a very, very expensive query if you need to enumerate them all. And yes, we can't do that in CTS, so that's one of the main drivers for looking at Optic. Also, ML12, we've heard about that vector functionality will be of great interest. We're looking at geospatial search, draw your bounding box on the map, find all the objects that were there. Personal saved collections, researcher comes in and finds a whole bunch of stuff from different museums. How can they collect those things together to come back to? Or how does the lecturer share their collection of objects with the class that she wants them to look at? More visualizations, I mentioned the timeline one, but also geospatial visualizations we're working on as well. And if you have tried it on mobile, it's terrible. We have the design for the refactor for the UI. It's just not quite implemented. And of course, if we were playing AI the drinking game, we would all be comatose by now. So yes, another mention of AI. We are looking at AI. In particular, Yale announced about 3 weeks ago that we will be spending $150 million over the next 5 years on AI across the university. So this is a high priority for the institution. So we're looking at the graph-assisted retrieval augmented generation process to help researchers. How do we get people to the information they need faster? The advanced search interface, if you know how it works, you can build really complicated, really interesting queries reasonably quickly. But it takes a bit of time to spin up on how it works. So what we'd love to do is use LLMs to take a natural language query to then build out the graph query from the natural language expression. We also want to put into place AI-powered services to increase the quantity and quality of the data in the graph. So now, thankfully, our place hierarchies are quite clean, and we solved that using LLMs to say, essentially, is Chicago part of Illinois? Yes. Is Illinois part of Chicago? No. Because, unfortunately, mostly data from the library, they were pretty interchangeable with the ordering, and so we ended up with many circular loops and other totally crazy hierarchies for place. Equally, we want to be able to detect just errors. So one of the earliest errors that we found was we did a query for the oldest person in Lux, and he was 39 trillion years old because someone had put the barcode for the CD into the death field. Who knows why? So yes, the year was in 39 trillion. So yes, how do we find errors before we are embarrassed by them going out live on the web? Named entity extraction from full text, reconciliation of entities can be improved with AI, and so on and so forth. So that is where we are heading, and with that, thank you so much for coming. We look forward to discussion and questions.
Are there any questions for these guys while they're up here?
Mm-hmm. Yep. Yep. So the question was essentially with multi-taxonomies, how do you deal with the variation of synonyms and labels and so on? So I can, maybe we'll jump out of the slides. So one of the ways that we do it is just by importing as much data into the system as we possibly can. And let's go to another. So here's the concept of fossils with primary name in 10, give or take, languages, non-preferred terms, additional names, et cetera, et cetera. So we don't have all of that in our systems. We bring it in from GBIF, from LC, from et cetera, et cetera. So that's the primary way. We do have stemming turned on, and in advanced search you can turn it off if that's a problem. We do not use semaphore because we have everything in MarkLogic. So we're certainly interested in looking into what that could add on top of this. But if I go back to the home page, the current counts of things, we would want to put 4.5 million concepts into semaphore, which could be expensive in terms of hardware. Yeah.
Well, I was just saying, we also have thesaurus at our disposal. We haven't used
Yep. Yep. Yeah. We also have the thesaurus functionality from MarkLogic, but we haven't turned it on because we haven't seen the need yet because of the enrichment. Also, we aren't confident that the thesaurial expansions wouldn't then conflict with the enriched data. So yeah, there's tools. So far, we haven't run into the need for them yet.
Come on, Steve. I know you want to.
Great. Yeah.
I noticed at the top of a lot of the entities, little boxes, related entities, works by.
Mhm.
Those look like special triples or special arrays. Are they fundamentally different, or how did you decide to put up top?
Yep. So go back to our friend. So the purpose of Lux is to get people to engage with the collections. So on the non-collection pages, on the people, the places, the concepts, the events, the prime real estate is taken up with what are the related things from the collections to bring you then back to list of pigments as an object, for example. So yeah, this is about 8 different paths through the graph, all of which are indexed, so it's very fast. Then there's another 10 or so for that one. That one's easier, that one's only 2. So
They're special in regards to driving back to
yeah,
your collection.
yeah. So the
They're not unique in the system.
yeah,
Okay.
yeah. So yeah.
I don't quite get it. I mean, if you were to click back on, for example,
Mhm.
there's so many things in blue. They're all ranked, and I assume every one of those things
Oh, yep.
might have a triple behind it.
Yep.
Then up top, it's just like these 3 separate things.
Right.
Yeah, yeah, yes. So it's essentially the different sorts of thing that you can go to. So this is objects, and then with the 3 or 4 relationships that we've sort of smushed together to make not many boxes across the top. So they're not special relationships. They're just kind of the ones that we want the user to see first. Yeah, and then the other ones we pull out into the accordions at the bottom. What are the related concepts to them? It's like, well, okay, but this isn't come back and see our collections. This is explore to find other things that you could be interested in. Yeah. Mhm. Yep.
All right.
Okay, I got one then. I like your comments on data sources. It's more of a business function, but I see that in there that you're gonna sell the data as a service kind of a thing, where you have people pay for that data.
You can, yeah, you can have the data today for free if you want
Charge
it.
him. Charge that guy.
Yeah. So the idea is, and so this is our not in production site with the crazy name of Lux by Unit 1, which has only a very small smattering of records available to it. So this is the photographic paper collection at the Institute of Preservation for Cultural Heritage. So of all 41 million records, these 10,000 odd have a role associated with them that then the middle tier does the query to MarkLogic to say, I'm querying as this role, so it ignores all of the other triples and documents and just has access to them.
It's like a free
But-
data as a service to Yale.
Yeah.
Yale libraries
Yep.
and museums.
Yep, yep.
Have you ever opened that up to other
Taking off all my hats. I personally, Rob, would love to do that. I think that it's the way we should be going, because at the end of the day, researchers do not care that the painting is is in New Haven, right, or owned by Yale. They're interested in Van Gogh, or they're interested in Trumbull, or they're interested in photographic paper from Kodak that we have some of, but the Getty has some, the Rijksmuseum has some, etc., right? So if there was a consortium that could come together to agree on how that would be funded, and this is where I put my Yale hat back on, like, Yale cannot be the repository for everyone's knowledge, as much as I would like us to. So there needs to be, some consortial agreements around how it would work, but we have, at the moment, no real question that this would scale to do that.
But I guess it's a good time to also say, and to clarify, MarkLogic, the product, is not open source, but MarkLogic, the code, the custom code, that is. The middle tier is open source. The front end is open source. The data pipeline is open source. And you put some effort into making it architectural decisions on, or implementation, so that you can plug in other sources to reconcile with or to enrich with.
Yep. Yep.
You don't have to start from scratch at least.
Yep. James?
Based on our conversation yesterday, can you share a little bit about how this might be used in courses?
So we have a committee in the Cultural Division, the Teaching and Learning Committee. They work with faculty to ensure that our collections are used as much as possible to enrich the lives of and learning of our students. We have already seen an entire course in English developed around locks. So they used to go to the library and do stuff. It's like, why would we do that now? We've got all of the information, all of the knowledge at the students' fingertips, wherever they are, and with all of this enrichment from all of the external sources, they can produce a much better experience for the students by using our much better user experience in Lux than they possibly could have in the past. We have looked into integrations with Canvas. We haven't gone there yet because we need to get requirements and et cetera, but that's certainly also on the cards.